Hello students, we are solving the IB Math A HL past papers and currently we are solving the IB Math A HL November 2021 paper 2. Today we will be solving the question 6 of this paper and you will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in the description area. So without any further delay, let us start answering question number 6. The maximum mark is 8. So part A says, prove the identity P plus Q whole raised to the power of 3 minus PQ times P plus Q is equivalent to PQ plus QQ. Okay, and it contains 2 marks. So let us first of all prove this. See, we are having two terms and both are having P plus Q as one of the factors. So I am taking that P plus Q as the common factor. So I am writing this as P plus Q, and from the first term we will be having P plus Q whole square, and from the second term we are having minus 3PQ. Okay. So this is equal to P plus Q and P square plus Q square plus 2PQ minus 3PQ, which is equal to minus PQ. Okay. And now we have to expand. So it is P cube plus PQ square. I'm taking minus PQ. Okay. So P times minus PQ is minus P square Q. Then it is plus QP square. Q times Q square is plus Q cube. And then Q times negative PQ is negative PQ square. Okay. And this is PQ square. This is negative PQ square cancel. And this is P square Q. And this is QP square. So they are also like terms, means they are equal. So we are having only PQ plus QQ. So proved. Okay. We have proved subpart A. Coming to subpart B. Before that, we are having these lines. The equation 2x square minus 5x plus 1 is equal to 0 has two real roots alpha and beta. Consider the equation x square plus mx plus n equal to 0 where m and n are integers. They may be positive integer or negative integer. They are integers. And which has roots. This quadratic equation will be having roots 1 over alpha cube and 1 over beta cube. So the subpart B says without solving 2x square minus 5x plus 1 equal to 0. If we solve this, we will be getting the two values of alpha and beta. The values of alpha and beta, and we can get the 1 over alpha cube and 1 over beta cube as well. And from there we can find the values of m and n, but we are not allowed to do that. We cannot get the values of alpha and beta. So without solving 2x square minus 5x plus 1 equal to 0, determine the values of m and n. Okay. So how can we do this? Obviously, we have to use the properties of the sum of roots, the product of roots, those things. Okay. Because otherwise we have to get the values of alpha and beta, which we cannot do. We are not allowed to do. Fine. And whenever they give something, they are not saying hence or otherwise, but you should be knowing that there may be a relation between this question and this subpart and this subpart. There may be. Not always will it be true, but sometimes it may be. So, can we use the identity? Let us see. We are having p cube plus q cube on the right hand side of the identity, and we are having 1 over alpha cube and 1 over beta cube. So, let p equal to 1 over alpha and q equal to 1 over beta. Okay. So p cube will be 1 over alpha cube and q cube will be 1 over beta cube. Clear? And from this equation, we are not allowed to use to get the individual values of alpha plus beta, but we know that alpha plus beta is equal to minus b over a. So b is equal to negative 5. So minus b will be negative of negative 5 is positive 5. So it will be 5 over 2, and alpha beta will be equal to c over a, that is 1 over 2. This we know, alpha plus beta equal to 5 over 2 and alpha beta equal to 1 over 2. And so let us now get the, since we have to get the values of m and n, what should the m and n values be? If we get 1 over alpha cube plus 1 over beta cube, that is the sum of the two roots, this should be equal to negative m over 1, which is equal to negative m, and if we take 1 over alpha cube times 1 over beta cube, this should be equal to n over 1, which is n. Okay, so we have to in fact get the values of 1 over alpha cube plus 1 over beta cube and 1 over alpha cube times 1 over beta cube. Okay, and for that we are starting from this point. Let p equal to 1 over alpha and q equal to 1 over beta. So p cube plus q cube should be equal to 1 over alpha cube. 1 over alpha whole cube is 1 over alpha cube plus 1 over beta cube. These are the sum of the two roots. Okay. This is, I'm just taking the left hand side of this identity. In place of p, I'll be writing 1 over alpha, and in place of q, I'll be writing 1 over beta. So this is 1 over alpha plus 1 over beta whole to the power 3 minus 3 times 1 over alpha times 1 over beta times 1 over alpha plus 1 over beta. Okay. So this should be equal to beta plus alpha over alpha beta whole cube minus 3 over alpha beta, and this is beta plus alpha over alpha beta. Okay. And now we will be substituting these values over here. So this is equal to alpha beta is 5 over 2. So 5 over 2 divided by alpha beta is half. So 5 over 2 divided by half is 5 over 2 multiplied by 2 raised to the power of 3 minus 3 times 3 divided by alpha beta means 3 divided by half, which is 3 multiplied by 2. And again alpha plus beta is 5 over 2 divided by half, which is multiplied by 2. So this is equal to 5 cube is 125 minus this is 3 times 2 is 6, 6 times 5 is 30. So this should be equal to 95, which is equal to minus m over 1. Therefore, m is equal to negative 95, an integer. Okay. Now coming to the product. 1 over alpha cube times 1 over beta cube is equal to 1 over alpha beta whole raised to the power of 3 equal to alpha beta is half. 1 divided by half is 2. So 2 raised to the power of 3, which is 8, which should be equal to n over 1. Therefore, n is equal to 8. Okay. So we have given them the values of m and n. Therefore, we have come to the end of this question. Thank you for staying with me till the end. I am Nilanjana Sanyal. I am an online IB Math A, HL and IB Math A SL level tutor, and I tutor students from both inside India and outside India. And currently, as you are seeing, that I am publishing videos on the solutions of the past paper questions of the IB Math AHL. So, in case you are liking my explanations, please do give this video a like and please do share this video with your friends so that even they can get benefited by watching these videos. And please do subscribe to my YouTube channel. Actually, these will be motivating me to make more math videos. And please don't forget to press the bell icon. You will be getting notified as soon as I publish a new video. Okay. And we meet again very soon in our next session where we'll be solving question number 7 of the same paper. So till then, bye.